Okay, in our last section of notes, we talked about a method in which you can solve a quadratic equation by using square roots. The limitation of that method was that you need to have only a squared term in your equation, not a linear term. So you couldn't just have an x by itself. It had to be an x squared or a binomial with x in it that was squared, but no single x in the equation. Today we'll look at a method that allows you to solve using square roots, even if you still have that single x alone by itself in the equation that you have. So this method is called completing the square, and we're going to be solving quadratic equations using this method. Now, this does require a little bit of review of factoring. So to factor this trinomial here, x squared plus 4x plus 4, you could use the trinomial pattern where you multiply a times c, and that's 4. And you need two numbers that multiply to 4 and also add to 4, which is the b value. And those numbers are 2 and 2. So you'll split that middle term and do x squared plus 2x plus 2x plus 4. And this allows you to then factor by grouping. So out of the first two here, x squared plus 2x, we can take out an x. We're left with x plus 2. Out of the second set, we can also take out a 2, leaving x plus 2. And then our final factored form is x plus 2 times x plus 2. Okay, not bad. Let's do the same thing for the second one. We need two numbers that multiply to 9 and add to -6. That's -3 and -3. So we split that middle term and factor by grouping. So we end up with x times x minus 3, and then we take a -3 out, leaving x minus 3 as well. So x minus 3 and x minus 3. Something you should notice here, and maybe we briefly talked about this in the factoring unit, but when you have a leading coefficient of 1, as we do in these two examples, the two numbers you find to satisfy those requirements are the two numbers you will see in the final factors. So for 4 we found it was 2 and 2, and for 9 we found it was -3 and -3. Also, remembering back in the polynomial multiplication notes, these are following the square of a binomial pattern, but just in reverse. So we can use all that information to predict that in this polynomial, since our two numbers that multiply to 25 and add to 10 are +5 and +5, our final factored form will be x plus 5 times x plus 5. Something else to notice about all three of these is that our final factored form is a perfect square because it is one binomial times itself. So these factors are perfect squares. And we can write those factored forms as this. So instead of x plus 2 times x plus 2, we can just write x plus 2 squared. Instead of x minus 3 times x minus 3, we can write x minus 3 squared. Similar for number 3, x plus 5 squared. And so these are called perfect square binomials. And again, that pattern from the multiplying polynomials unit matches this method. So let's talk about completing the square. So we are allowed to do this, go straight to this binomial here squared because of the perfect square pattern that shows up. And so we can figure out what number would have to go here in the constant position based on the middle number of our trinomial. So to find that constant, we take the middle number, the b value, divide it by 2, and square it. So b over 2 squared. You can see that here. So we have x squared minus 10x plus something. To make this a perfect square trinomial, which will give us the perfect square binomial pattern, we take this middle number, negative 10, divide it by 2, which is negative 5, and then square that. Negative 5 squared is 25. So we do negative 10 divided by 2, and then square it, and that equals 25. For b, 20 is our b value, divided by 2 is 10, and 10 squared is 100. And for negative 14, divided by 2 is negative 7, squared is 49. And 24 divided by 2 is 12, 12 squared is 144. Notice for all these we get a positive answer, even if the b value is negative, because a negative number squared is always going to be positive. So here again is that pattern. If you have some binomial squared, you get this trinomial pattern. So a squared plus 2ab plus b squared. And we get that from distributing a squared plus ab, that's the 2ab, and then plus b squared. So you can also go in reverse. If you start out with one of those perfect square trinomials, you can find the binomial at the end by taking the square root of a squared and the square root of b squared and making that binomial. Just a note though, if 2ab is negative, like we see right here, then we use a negative sign in that final binomial. So we can take the square root of the first term, the square root of the last term, and then use the sign that's on 2ab in our final binomial. So let's use this pattern to factor the examples up here from example 1. So example A was x squared minus 10x plus 25. So we can use this pattern to just know that our factored form is the binomial x, that's the square root of x squared. The square root of 25 is 5. The negative sign here gives us a negative sign here, and then it's just squared. So x minus 5 squared is the factored form of that trinomial. Let's look at example B, which was x squared plus 20x plus 100. So x squared plus 20x plus 100. All right, so our first part of our binomial is x, the square root of x squared. We have a positive on 2ab, so plus the square root of 100 is 10, and there's our factored form. So we can use all the information we already know about how to factor a trinomial to take this shortcut. We're skipping all the work because we can predict, we can use the pattern to predict what the answer will be. Example C was minus 14, so x squared minus 14x plus 49. Our factored form here is x. We have a negative sign, so minus the square root of 49 is 7 squared. And for the last one here, 24, so x squared plus 24x plus 144. Start out with x. We have a positive here, so plus the square root of 144 is 12 and squared. Now, this isn't the whole thing. So this is how we can factor or change a perfect square trinomial into a squared binomial. And the reason we want to be able to do that is we can use this method to solve a quadratic equation, which we can turn into or find a perfect square trinomial within. So here's the process. It'll make more sense once we do some examples. So if the trinomial is not a perfect square trinomial, we have to find the right number to complete the square and then solve by square rooting. So we're going to move the constant terms all to one side if it's not a perfect square trinomial already. And then we'll find the value that will make it a perfect square trinomial by doing that b over 2 squared process. We'll add that number to both sides of the equation and then factor and solve and simplify if we can. And like I said, doing the examples will make more sense. So let's look at this first one. We got x squared minus 6x plus 9 equals 25. Here is our trinomial, and we should test to see if it is a perfect square trinomial before we start doing things. So take the middle term, divide by 2, and square it. So 6 divided by 2 is 3. 3 squared is 9. So that works out. This is a perfect square trinomial. We can just factor this part. So ignore the equals 25 for now. We'll just factor this thing. So just like we practiced, we have a binomial here, and the square root of x squared is x. The square root of 9 is 3. And because of this negative sign, we have a minus. And this is squared, right? So this is how we factor x squared minus 6x equals 9. And it's still equal to 25. And now we can solve by square rooting. So we'll take the square root of both sides, just like we did in the 7.2 notes. We get x minus 3 equals positive and negative 5. And then we just add 3. So x equals 5 plus 3 is 8, and negative 5 plus 3 is negative 2. So we get the two numbers, 8 and negative 2. For example B, again, we need to check our trinomial. So 10 divided by 2 is 5. 5 squared is 25. So it works out. So we can just factor it. So we get x plus, because of the positive sign here, the square root of 25 is 5 and equals 81. And now we have an isolated squared term that we can use to solve by square rooting. So we'll take the square root of both sides. X plus 5 equals the positive and negative square root of 81, which is 9. Subtracting 5 from both of those numbers, we get x is equal to 9 minus 5 is 4. Negative 9 minus 5 is negative 14. So there are our two solutions there. Okay, let's check example C. 8 divided by 2 is 4, and 4 squared is 16. Well, 5 is obviously not 16. So we do need to adjust this. Let's go ahead and subtract 5 from both sides. Move the constants all the way over. And when you do this, I'd leave a little space. So x squared plus 8x, leave a little space, equals negative 5. And so we need to complete the square. And again, like we were checking, 8 over 2 squared, that's 4 squared, that equals 16. So we need to add 16 to both sides of this equation. And now we have a perfect square trinomial that we can factor. And that would be x plus 4 squared. The square root of x squared is x. The square root of 16 is 4. Okay, so that's how we get that binomial. And it equals negative 5 plus 16, which is 11. So from here, we take the square root of both sides. X plus 4 equals the positive and negative square root of 11. And then we will subtract 4. So x is equal to positive and negative square root of 11 minus 4. Okay, so if it's not a perfect square trinomial, we need to adjust our equation to make sure that we get a perfect squared trinomial. Let's try the next one. Again, check it first. 16 divided by 2 is 8. 8 squared is not 16. So we're going to need to do a little adjusting first. We'll add 16 to both sides. So x squared minus 16x, leave some space, equals 0 plus 16 is 16. And now we need to figure out what goes here. And again, 16, negative 16 over 2 squared, well, that's 8 squared, which is 64. So we need to add 64 to both sides here. And this is what it means to complete the square. We're completing the perfect square trinomial so that we can factor it. And this particular one factors into x minus, because of the negative sign right here, x minus the square root of 64 is 8 squared, and it equals 16 plus 64, which is 80. And now we'll take the square root of both sides. So x minus 8 equals, now the positive and negative square root of 80, which we can simplify. Let's go ahead and do that. So the square root of 80 is the same thing as 16 times 5. And so 16 is the biggest perfect square factor of 80. The square root of 16 is 4. So this is 4 square root of 5. Final step here is to add 8 to both sides. So x is equal to the positive and negative, and we'll use our simplified version, 4 square root of 5 plus 8. And there's your final answer. Doesn't look pretty, but it's okay. It is still the correct answer. All right, let's look at example E. Clearly, we don't have a perfect square trinomial here, so we can go ahead and go straight to this step. X squared plus 20x, leave some space, equals negative 104. We have to decide what number to add here. So 20 over 2 squared, that's 10 squared, which equals 100. So we're going to add a 100 to both sides here. And then we can factor this perfect square trinomial. So we get x plus the square root of 100 is 10. And this is equal to negative 4, negative 104 plus 100. So we'll go ahead and take the square root. We get x plus 10 equals positive and negative 2i. Don't forget, the square root of negative 1 is I. So we get positive and negative 2i. Then we're going to subtract 10. So x equals positive and negative 2i minus 10. And there's a good solution there. One more. Again, we should check and make sure. 14 over 2 is 7. 7 squared is 49, so we do need to move that 28. So x squared plus 14x, leave some space, equals negative 33. And like we just found out, we are going to add a 49 here. 7 squared is 49. And we can factor this trinomial. So that's x plus 7 squared equals 16. That's nice. That is a perfect square. So when we take the square root, we get x plus 7 equals the positive and negative square root of 16, which is 4. And then minus 7. So x is equal to 4 minus 7 is negative 3, and negative 4 minus 7 is negative 11. So very similar to the previous section of notes, except now we have one more tool we can use to solve an equation by square rooting, even if we have a linear term, an x by itself, a singular x term. We can complete the perfect square trinomial, factor it, and then solve by square rooting.